Every physicist alive knows this. Almost no one else does. The Earth is not orbiting the Sun. It is falling toward it. Right now. At this moment. You are on a planet in continuous freefall toward a star. You are moving sideways fast enough that the Sun's surface curves away beneath you at exactly the rate you fall toward it. That is not a metaphor. That is the literal, physical description of what an orbit is. If the Earth is falling to lid, what is it falling through? And what happens when that thing changes? In 2020, the European Space Agency published data suggesting the medium Earth moves through is not empty vacuum. 3 space agencies, 3 missions, something measured in the space between Earth and Sun that their own models say should not be there. The Earth's fall is being affected by something. If the trajectory deviates where are we going? The Earth's actual trajectory deviates from the Newtonian prediction. Small. Consistent. Real. Earth's orbital speed is 29.78 kilometers per second. It is 149.6 million kilometers from the Sun. In the time it takes to read one sentence dice, the Earth has moved 300 kilometers. The gravitational pull of the Sun at Earth's distance, 0.006 meters per second squared. A continuous inward acceleration, always. 3 separate space missions in the last 15 years. Quietly measuring why the actual trajectory deviates. One element in the space between planets. Every calculation assumes it is negligible. The measurements suggest it is not. In 2002, NASA noticed both Pioneer spacecraft decelerating faster than all known gravitational forces could account for. The Pioneer Anomaly, an excess deceleration of 8.74 times 10 to the power of minus 10 meters per second squared. In 2012, the anomaly was attributed to anisotropic thermal radiation. The Pioneer anomaly was considered closed. What did not close? In 2016, 6 additional spacecraft showed the same type of trajectory anomaly. Different trajectories, different thermal profiles. 6 spacecraft, 6 separate thermal profiles, the same directional bias, pointing toward the same region. The directional bias points toward the region through which the Earth's own orbital path passes twice every year. Twice every year, the Earth crosses the zone every spacecraft anomaly points toward. Interplanetary dust, distributed throughout the inner solar system. The Earth falls through it. Every standard model treats the effect as 0. LISA Pathfinder, launched 2015, designed to detect gravitational waves. In doing so, it measured something else. The most sensitive acceleration measurement ever performed, femtometers per second squared. And the residuals the forces it could not account for were real. The LISA Pathfinder residual accelerations. Consistent in magnitude with the Pioneer anomaly, consistent in direction. 3 different positions. 3 different measurement principles. 1 directional bias. When researchers cross-referenced the LISA Pathfinder residual data with the interplanetary dust density measurements they found something already there. The residual acceleration is larger where the dust density is higher. 2 separate instruments. 1 spatial correlation. The Earth passes through regions of varying dust density twice every year. The standard model does not incorporate this as a variable. WISE. Stereo. LISA Pathfinder. 3 missions. The data analyzed together suggests measurable drag. There is no published model of the Earth's orbit that incorporates real-time interplanetary dust density as a variable. None. Every spacecraft ever launched, every trajectory calculated, all use a dust-free model. What came next changed everything. And almost nobody reported it. In 2019, a Max Planck Institute team analyzed LAGEOS satellite laser ranging data. Millimeter precision. The magnitude was consistent with the Pioneer anomaly and the LISA Pathfinder residuals. But the direction was different. The LAGEOS anomalous acceleration was not pointing toward the Sun. It was pointing toward the galactic center. A signal in the orbital data of satellites in the Earth-Moon system, pointing toward the center of the Milky Way. 26,000 light-years away. The galactic tide, the gravitational pull of 200 billion stars on every object in the solar system, measurable in Lagrange data. If the galactic tide is detectable in Lagrange data, the Earth's own orbit is being measurably shaped by the mass of the entire galaxy. 3 forces, none in the standard model, all measured, all real, shaping the fall of this planet. The ESA LISA mission, scheduled for the 2030s, will measure acceleration environments with precision orders of magnitude beyond anything current. When LISA flies, the residuals, the directional anomaly, the galactic tide, all will be measurable simultaneously. The Vera Rubin Observatory will produce the most detailed map of inner solar system dust density ever compiled. What it finds will test the drag model directly. What may be permanently unknowable, whether the directional anomaly has a single source pass or represents several independent phenomena pointing the same direction. You now know that the Earth is falling through a medium that is not empty, being dragged by material no orbital model accounts for, and being shaped by a tidal force from a structure 26,000 light-years away, that no current solar system model fully incorporates. The fall has never been simple. It has always been through something. The fall is real. The medium it falls through is not what the textbook describes. The Pioneer anomaly was considered resolved. The LISA Pathfinder residuals remain open. The Lagrange galactic tidal signal has 1 published paper and no follow-up. 1 paper, no follow-up. The galactic tide measurable in low Earth orbit TAD, and no one has published a response. The interplanetary dust drag has been measured by 3 missions and incorporated into 0 orbital models. The standard model contains 1 dominant force. 3 additional forces have been measured. None are in the model. Right now, you are on a planet falling at 29.78 kilometers per second, through a medium that is not empty. The Sun orbits the galactic center. The Earth orbits the Sun. Nested falls, all the way down, all the way up. The deviations are small enough that the Earth's orbit is stable on any timescale relevant to human civilization. But stable is not the same as fully understood. Over millions of years, the uncounted forces accumulate. The orbit we predict and the orbit we will follow are not identical. The question from the beginning: if the Earth's fall is being affected by something not in the standard model, say, where are we going? The honest answer: the deviations are small, the orbit is stable, but the model is incomplete. The Pioneer anomaly, officially resolved. The 6 additional spacecraft anomalies, not resolved by the same explanation. The LISA Pathfinder residuals, open. Stable is not the same as fully understood. The fall has always been through something. Right now, the Sun is pulling you inward at 0.006 meters per second squared. The interplanetary dust is applying a drag your model ignores. A directional anomaly of unknown origin is nudging the trajectory of every spacecraft in the inner solar system. And the galactic tide, the gravitational pull of 200 billion stars pars, is measurably bending the path of satellites in low Earth orbit, 26,000 light-years. The gravitational tide of the galaxy, measurable in a satellite 400 kilometers above your head. The fall has never been simple. It has always been through something. That something is more than the textbook describes. The medium it falls through has been measured, has structure, has forces, has effects, and is in no current orbital model. Every physicist alive knows the Earth is falling. What they have not fully agreed on is what it is falling through. LISA will fly in the 2030s, the next generation of measurement. The anomalies will either resolve or deepen. You now know what the Pioneer tracking revealed, what LISA Pathfinder measured, what the Lagrange data contained. The fall varies with what it falls through. The density of the medium changes along the orbit. The drag changes with it. Most people know the Earth orbits the Sun. You now know what orbiting actually means to FRAV, and what is making it slightly different from what the model predicts. 3 measurements, 3 unresolved anomalies, 1 planet that has been falling through all of it since the solar system formed. The fall is real. The medium it falls through is not empty. The model that describes the fall is incomplete. These are not contested facts. These are measurements. This is what the space between the Sun and the Earth actually contains. This is what the Earth is actually falling through. The next generation of gravitational sensors, LISA, will measure what LISA Pathfinder began. The investigation of what we fall through has already begun. Twice every year, the Earth passes through the densest dust concentration, the drag at its maximum, uncounted in every model. You are on a planet falling through space right now. The medium is not empty. The model is not complete. The galaxy is pulling the LISA satellites right now. The measurement is in the data. The mechanism is the published explanation. The follow-up has not been done. The next investigation goes further, Hap, into what the next generation of gravitational sensors will find when they measure the medium through which we fall with LISA-level precision. The Earth is falling. The medium it falls through is not empty. The model that describes the fall is adequate fraud, but incomplete. Every physicist knows the Earth is falling. Almost no one knows what it is falling through. Now you do. Pioneer 10 and 11, both traveling outward, both carrying the anomaly that opened the question. Still out there now, silent. This planet has been falling since the solar system formed, 4.5 billion years, through a medium that has always been more than the model describes. And the galactic tide hive, 200 billion stars hide, bending the path of satellites right now. At this moment, while you watch this, the fall, ongoing, unmeasured in its full complexity. For 4.5 billion years, the most sensitive orbital measurements ever made, Pioneer, LISA Pathfinder, Logos, all found something the standard model does not contain. The next investigation. What LISA will find when it measures the medium of the fall with the precision it was built for. It has been falling since before the first human looked up. It was falling before the first physicist described what falling through space meant. It is falling now.